Alright, today we are looking at multiplying and dividing monomials. A monomial, mono just means one, so a monomial means it has one term. So there's no pluses, no minuses. Okay, so if we look at this first one, we have 5 squared times 5. So we talked about exponents and powers last time, but notice these are both 5s. Okay, and remember, if there's no exponent, like on the second 5 here, this is just a 1. This is like 5 squared times 5 to the first. Remember that 5 squared really just means 5 times 5. Okay, and then 5 to the first is just another 5. So really we have 5 times 5 times 5. And that's the same as 5 to what power? There's 3 of them, so that's going to be 5 to the third. Okay, so you can obviously write it out like that every time, but there's kind of a shortcut to do this, and that's just looking at your exponents up here, knowing that that's a 1, you can just add those together. So 5 squared times 5 to the first is just 5, your base stays the same, 5, and then you do 2 plus 1. Okay, so 5 to the 2 plus 1, which is the same as 5 to the third. Okay, now when it says simplify, usually it wants you to leave it in exponent form like this. If it said evaluate, then you would want to keep going and say, what is 5 to the third? Well, that's 5 times 5, which is 25, times another 5, which is 125. Okay, so usually simplify means this one. Evaluate is wanting something like that. Okay, we can do the same thing with variables. Okay, so we have c to the third times c to the fifth. Again, this is c to the third is c times c times c. C to the fifth is 5 of these, c times c times c times c times c. So if you notice, we have a total of 1, 2, 3, 4, 5, 6, 7, 8 c's. So this is the same as c to the 8th. Okay, and again, our base is the same, they're both c. So our base will stay c, and then we'll just add the exponents. So 3 plus 5, which comes out to be c to the 8th. Okay, so this brings us to our first exponent rule, which is this one right here. So it's a product of powers. Product means you're multiplying. So to multiply powers with the same base, okay, same base, it's got to have the same base number, you just add their exponents. So again, 2 to the fourth times 2 to the third is just going to be 2 to the seventh, because you add 4 plus 3. Your base always stays the same. A to the m times a to the n, they have the same base of a, and you just add m plus n. Okay, so that's the rule. So you can try a couple here. I'll do C, and then you guys can do A and B. One second. Alright, so I think I was about to do C. So C, if you look at C, this one you have your M's here and here. So let's just focus on those for a minute. So we know that when we multiply those together, we're going to get a base of M still. And this, because there's no exponent here, we know that's m to the first power. Okay, so m to the first times m to the fifth, you're going to add these two. Okay, don't multiply them, you're adding the exponents. So 1 plus 5 gives us m to the sixth. Now these numbers right here aren't the same. So 8 and negative 2. Those aren't the same. So we're not going to worry about exponents with those. All we're going to do is just multiply those together. So negative 2 times negative 8. 2 times 8 we know is 16. So that's going to go right in front here. Negative times negative, those cancel each other out and make positive. Okay, so your simplified form should just be 16 m to the sixth. Okay, so you only worry about the exponents with when your bases are the same, like your m's here. Otherwise, you just multiply. Usually, you just multiply the numbers together anyway. So negative 2 and negative 8, multiply them together. All right. So again, try A and B, and then I'll move on to the next one. Okay, so now we are dividing. Okay, so I'm going to write this out a little bit. So look at number 4 here. So if I write this all out, 4 to the 8th, it's going to be 4 eighths on top. oops. So 1, 2, 3, 4, 5, 6, 7, 8. And then I have 2 on the bottom. Okay, so when you have fractions like this, remember that if you have the same factor on top as the bottom, they'll cancel out. So factor means something that's being multiplied. So we have all these 4's on top that are multiplied, and these 2 4's on the bottom that are being multiplied. So I can cancel out a 4 on the top with a 4 on the bottom, so those will cancel. And I have 2 of them, so I can cancel out 2. And I'm just left with 1, 2, 3, 4, 5, 6 4's on the top. So my denominator's gone, so I don't need to worry about a fraction anymore. So I'm just going to write that as 4 to the 6th power. Okay, so if you notice, how can we get 6 out of 8 and 2 here? Because notice your 4, again, is the base, so that stays the same. So when we have 4 to the 8th divided by 4 squared, we're dividing instead of multiplying, so we're doing the opposite. Okay, so instead of adding your exponents, we're just going to subtract them. So this is the same as 4 to the 8 minus 2. Okay, which again gives us 4 to the 6th. That's just because they all cancel out. So you always do the top exponent minus the bottom exponent if your bases are the same, like these 4's. Okay, so same idea applies to number 5, so I'm going to let you guys do that one. Look at number 6, we have a couple different things going on here. Okay, so when you look at these, I want you to look at them all separately. So look at your 2's first. These are kind of blurry, but look at your 2's. So I have 2 to the 5th divided by 2 squared. So how many 2's will cancel out? Okay, there's going to be 2 on the bottom that cancel from 2 on the top. So that's going to leave us with 2 to the 3rd, because again you can do 5 minus 2. Then we look at the 3's here. Okay, 3 to the 5th on top, 3 to the 4th on the bottom. So I'm going to be left with 3 to the 1st, or you can just put 3. And then look at your 5's. So we have 5 squared on top. This is really 5 to the 1st, remember. So 1 5 will cancel from the bottom and the top. So I'm just left with 5 left on the top. That's 5 to the 1st. So we get 2 to the 3rd times 3 times 5. And again, if it said to evaluate that, we would just go ahead and figure out what 2 to the 3rd is, which is 8. 8 times 3 times 5, and figure out what that answer is. But it just says to simplify. Okay, so this is fine. Alright. So again, the rule here, to divide powers with the same base, you subtract the exponents. So that's the quotient of powers. Quotient means division. Okay, so for example, 3 to the 7th divided by 3 to the 3rd, you still keep your base of 3, but then you subtract the exponents, 7 minus 3. So we get 3 to the 4th. And again, you always do the top minus the bottom. And if we look at it in algebra form, a to the m over a to the n, same base of a, and you just subtract m minus n. Okay, this says where a is not 0. It's just saying that because you can't divide by 0. Okay, that's one of the most important rules in math. You can't split 10 things into 0 groups, so you can't divide by 0. So don't get confused about that part. Alright, next slide, where are we at? Okay, lots of examples here. So, let me do a couple of them. Okay, so D and E are things we've been doing, so let's look at F. Okay, so again we have these numbers here, so 12 and 2. Notice there's no exponents on those. Okay, so don't think about subtracting them. You're not going to subtract 12 minus 2, because those are not exponents. All we're going to do with those is you're just going to divide them like normal, because they're just regular numbers. So 12 divided by 2 gives us 6. Okay, let me erase this a little bit. Okay, and then we look at the W's next. Okay, so we have W to the 5th over W. Again, that's W to the 1st, really. Okay, so then we just subtract 5 minus 1 gives us same base of W to the 4th power. Okay, so when you have your whole numbers, don't subtract them unless they're like these ones on G. Okay, because those do have exponents. If they have exponents, you can subtract the exponents, but don't subtract the actual numbers, like 12 and 2 here. Okay. The rest of these are pretty straightforward. I think you can do. Yeah, go ahead and try those. We'll talk about some of them in class tomorrow. And our last slide here. I think it's the last one. Yes. Okay. So this one, it says Hawaii's total shoreline is about 2 to the 10th miles long. New Hampshire's shoreline is about 2 to the 7th miles long. About how many times longer is Hawaii's shoreline than New Hampshire's? Okay, so this, you have to figure out what operation you want to use. So are we adding, are we subtracting, are we multiplying, or are we dividing? Okay, so it wants to know how many times larger Hawaii's shoreline is than New Hampshire's. So basically, how many times will New Hampshire shoreline go into Hawaii's shoreline? So this is actually a division problem. So we're going to divide Hawaii divided by New Hampshire. Okay, and Hawaii's about 2 to the 10th miles long, divided by New Hampshire's, which is about 2 to the 7th. Okay, this will tell us how many times New Hampshire's shoreline will fit into Hawaii's. So then we just divide these, and again they have the same base of 2, so I actually don't need that fraction line. So it's going to result, these units cancel, so we get 2, and then I'm going to subtract the top, 10 minus 7, which gives us 2 to the 3rd. Okay, 2 to the 3rd comes out to be 2 times 2 is 4, 4 times 2 is 8. Okay, so this tells us that Hawaii's shoreline is about 8 times larger than New Hampshire's. Oops. Alright, and that is all for this one. So remember to take the quiz on Canvas before 8:25 tomorrow so you can get full points for it.